ऑर्गेनिक कंपाउंड्स जिनमें फंक्शनल ग्रुप में नाइट्रोजन एटम प्रेजेंट होता है उनको लेकर सबसे पहले एक इंट्रोडक्टरी पार्ट लेते हैं। ऑर्गेनिक कंपाउंड्स विथ फंक्शनल ग्रुप्स containing nitrogen. नाइट्रोजन कंटेनिंग फंक्शनल ग्रुप्स की जब हम बात करते हैं तो द कैटेगरी ऑफ कंपाउंड्स विच आर इंक्लूडेड दे आर अमीन्स, साइनाइड्स एंड आइसोसाइनाइड्स एंड द नाइट्रो कंपाउंड्स मीन्स नाइट्रो अल्केन्स और अरीन्स एंड द अल्काइल नाइट्राइड्स. In these all compounds, the first part which we are going to cover up is about the amines. So the organic compounds with functional groups containing nitrogen, this will involve different categories of compounds in which we are starting amines. जो amine compounds होते हैं, they are considered to be the hydrocarbon derivatives of ammonia. हाइड्रोकार्बन डेरिवेटिव्स ऑफ अमोनिया की यदि हम बात करें तो एज वी नो दैट द फॉर्मूला ऑफ अमोनिया इज NH3, बट इन द हाइड्रोकार्बन डेरिवेटिव्स वी कैन कम अक्रॉस द डेरिवेटिव कंपाउंड इन विच one of the 3 hydrogen atoms of ammonia is replaced by alkyl group. This compound is called as primary amine. This category is called as primary amines. In the second category, there can be 2 alkyl groups in place of the 2 hydrogen atoms of ammonia. So this way, the general formula R2NH will correspond to the category secondary amines. On the other hand, we have one more category, that is the category in which all the 3 hydrogen atoms of ammonia are replaced by the 3 alkyl groups. This category is called as tertiary amines, or we also write them as 3-degree amines. So primary amines are the compounds in which the functional group is NH2, secondary amines have NH with the 2 hydrocarbon structures bonded, and the tertiary amines are the tri-alkyl derivatives of ammonia. We have one more thing here. The hydrocarbon structure can be an aliphatic hydrocarbon structure or it can be an aromatic hydrocarbon structure. If it is an aliphatic hydrocarbon structure in the primary amines, this will be called as aliphatic primary amine. Similarly, we can have aliphatic secondary amines, aliphatic tertiary amines. Instead of the aliphatic hydrocarbon parts, we can also have aromatic hydrocarbon structures. In the aromatic hydrocarbon structures, the compounds will be categorized as aryl amines. Aryl amines means when the hydrocarbon part is an aryl group. So these are the alkyl amines or aliphatic amines, and we can also have the aromatic amines or the aryl amines. In the aryl amines, when we talk about the common primary amine, that is benzene amine. In the compound benzene amine, the common name given to this compound is aniline. Structurally, definitely the presence of lone pair on nitrogen along with the conjugative system will create a bigger difference as compared to the aliphatic amines. Even if I compare any of the aliphatic amines with aromatic amine, we shall find the difference in properties, a huge difference in properties. Now, with the introduction, we should also understand that along with this aniline, we can also have the secondary and tertiary amines in which one of the hydrocarbon part is aliphatic and another is aromatic. So this way we can have very different categories in the amines. Categories may be on the basis of the derivation of ammonia, how are they derived. The categories may also have a difference of the hydrocarbon part, that may be aliphatic hydrocarbon part or the aromatic hydrocarbon part. Now, to understand all these things in a better manner, let us come to some comparison of isomeric compounds, some comparison of the compounds with nomenclature also. So, you can try in the beginning for the introduction with the amines, the different isomers of molecular formula, isomers of molecular formula C4H11N. This is a molecular formula given here, and you have to try the different amine isomers related to this molecular formula. Just you can try the isomers, try their IUPAC names, try their relationship also. What is the isomeric relationship in the different compounds? C4H11N, that is the molecular formula we have to follow. I start with the answers. The first compound that we can have is the simplest one, in which 4 carbon are in the straight chain with amine group on the first carbon. We can also have 4 carbon in the straight chain with amine group at the second carbon. We can also have a compound with parent chain of 3 carbon, amine group at the first carbon and a methyl branch at the second carbon. In the same category we can also have one more case here. The parent chain is of 3 carbon. There is a methyl branch and NH2 group. Branch and NH2 group, they are at the second position. These 4 isomers of the molecular formula C4H11N, they all are in the category of primary amines. So this is the list of the 4 primary amines possible from C4H11N. Among the 4 primary amines, the name given to the first will be butane 1 amine. The name given to the second one is butane 2 amine. The third one will be named as 2-methyl propane 1 amine. 2-methyl propane 1 amine. The last one is 2-methyl propane 2 amine. So these are the 4 compounds which are in the categories of primary amines. Now we can also have secondary amines following the same molecular formula. The secondary amine with the same molecular formula can be this amine. The name given to this will be N-ethyl ethane amine. It is N-ethyl ethane amine. This is also one of the possible secondary amines. Secondary amines में एक ये वाला भी possible होगा. The name given to this will be N-methyl propane 1 amine, because the position of this N-methyl amine group is at the first carbon of propane. Because we can also have this N-methyl amine group at the second carbon of propane. The parent hydrocarbon structure is propane, and at the second carbon we have N-methylamine group. So these are the three possible secondary amines with the molecular formula C4H11N. Now just think on the molecular formula, look at the molecular formula, just try to find any other possibility. Could you find any other possibility? Yes, we can also have a tertiary amine related to the same molecular formula. A tertiary amine is also possible. The name given to this will be NN-dimethylethanamine. NN-dimethylethanamine. That is the compound, that is the IUPAC name for this tertiary amine. I have mentioned all the possible primary, secondary and tertiary amines here. Now let us compare the important thing, that is about the isomeric relationship. Isomeric relationship of these compounds. This and this are butane 1-amine and butane 2-amine. Since they have difference of only position of NH2 group, they are the position isomers of each other. If I compare first with the third one, so they have a difference of carbon atoms in the parent chain. It has 4 carbon in the parent chain, it has 3 carbon in the parent chain. So that way the first and the third will be considered to be the chain isomers. Similarly, when I compare this first with the last one, this fourth one in the category of primary amines, these two will also have the chain isomeric relationship. Why are they chain isomers? Because the parent chain of this compound has 4 carbon atoms, the parent chain of this compound has 3 carbon atoms. If I compare this second with the third one, they again have a difference in number of carbon in the parent chain. Here is the parent chain of 4 carbon, here is the parent chain of 3 carbon. So again the chain isomeric relationship. Second with fourth, again the chain isomers, they are the chain isomers. But when I compare this third with the fourth one, the isomeric relationship is now positional isomer. They are the position isomers. How are they position isomers? Just recall their names. This compound is 2-methyl-propane 1-amine and this compound is 2-methyl-propane 2-amine. When the entire name is same, only the difference is in the numbering of certain branch or group or whatever, then we call them position isomers. So that way these two have a difference in position of NH2 group. Otherwise, other things are all same. So that way they are position isomers. No, I did not compare any of the primary with any of the secondary up till now. The reason is very clear, that they belong to different homologous series. The homologous series of primary amines is considered to be different from that of the secondary amines. It is considered to be different from that of the tertiary amines. So what is the conclusion? If I compare any of the primary amines with any of the secondary or tertiary amine, then that particular relationship will be taken as functional group isomer. They are the functional group isomers. Because when you have the same molecular formula but different structures, and those structures belong to different homologous series, then the relationship is called as functional group isomeric relationship. So that way it is an obvious relationship. If I compare any of the primary with any of the secondary or the tertiary amine, then it will be functional group isomeric relationship. But here we have an important comparison of these two. Both of these are the secondary amines. In case of secondary amines, I consider that this functional group is a bivalent functional group. Try to understand this word, bivalent functional group. The functional group has two valencies. With the same molecular formula, when the two valencies are satisfied by different types of hydrocarbon structures, then they are called as metamers. So remember that this first and the second are the metamers of each other. This first and the third are also metamers of each other. Metamers differ in the hydrocarbon structure on the two valencies of the bivalent functional group, the functional group with two valencies. So this with this with this, these have metameric relationship. However, if I compare these two, they are actually the position isomers. Once again, I'll request you to just recall their IUPAC names. The IUPAC name given to this is N-methyl propane 1-amine, and this is N-methyl propane 2-amine. So how are they different? They are just different in the position of N-methyl amine group. The N-methyl amine group has different position in this and this. Finally, if I compare this compound with any of the previous compounds, that will be the functional group isomeric relationship. I hope you could understand the molecular formula C4H11N. एक पॉइंट यहां पर और फोकस करने वाला है फ्रेंड्स, जैसे कि अदर फंक्शनल ग्रुप्स में क्या होता है, जैसे यहां पर यदि अल्कोहलिक ग्रुप OH ग्रुप होता या कोई हैलोजन सब्स्टिट्यूएंट प्लेस्ड होता, तो हम उनकी कैटेगरीज प्राइमरी, सेकेंडरी या टर्शरी इस बेसिस पर दिए होते कि जो कार्बन एटम्स जिनसे अटैच्ड वो फंक्शनल ग्रुप है वो कैसे हैं. सपोजिंग दैट OH group is present in place of NH2. So this would be primary alcohol and this would be considered as secondary alcohol, and this would be considered as the tertiary alcohol. NH2 की जगह OH होता तो. But amines में ऐसा नहीं है. We do not look at the carbon. Rather we look at the type of functional group. Of course, यदि ये स्पेसिफाई करना हो कि प्राइमरी अमीन ग्रुप कैसे कार्बन एटम से अटैच्ड है, तो नो डाउट इसे आप बोलेंगे कि ये प्राइमरी कार्बन से अटैच्ड है. यहां प्राइमरी अमीन ग्रुप सेकेंडरी कार्बन से अटैच्ड है. प्राइमरी अमीन ग्रुप सेकेंडरी कार्बन से अटैच्ड है. सो फॉर दिस पर्पस वी हैव टू बी केयरफुल. अमीन्स आर प्राइमरी, सेकेंडरी एंड टर्शरी on the basis of number of hydrocarbon parts that have replaced the number of hydrogen atoms